General Motors sold over 500,000 diesel engines to American families. Nearly half of them failed. One engine, one decision. It poisoned an entire country against diesel cars for 40 years. Here's how. October 1973. The Arab oil embargo hits. Gas prices don't just rise, they double overnight. Americans who'd spent decades buying land yachts with 8-mile-per-gallon V8s suddenly found themselves waiting in lines that wrapped around the block. Some stations ran dry completely. Others started rationing. You could only fill up on certain days based on your license plate number. The party was over. Washington responded the way Washington does. They passed regulations. The corporate average fuel economy standards, CAFE for short, landed on Detroit's desk like a bomb. By 1985, every automaker had to hit a fleet average of 27.5 miles per gallon. For context, the average American car in 1973 got about 13. GM needed to nearly double their fuel economy in 12 years. Now here's where it gets interesting. While Detroit panicked, Mercedes-Benz was quietly printing money. Their diesel sedans, the 300D and 240D, had waiting lists stretching 2 years. 2 years. People were writing checks for cars they wouldn't see until 1976. Diesel sales for Mercedes jumped 400% during the crisis. 400%. GM executives watched those customers signing on dotted lines and saw dollar signs. Diesel made perfect sense on paper. 30% better fuel economy than gasoline, longer engine life, lower fuel costs. European manufacturers had proven the technology worked. Mercedes had been building diesels for 50 years. Peugeot had decades of experience. Even Volkswagen was selling diesel rabbits. The GM board made their decision. They wanted a diesel. They wanted it in full-size cars, and they wanted it fast. The timeline they gave their engineers was 36 months, 3 years to design, develop, test, and launch an engine technology the company had never touched in passenger vehicles. Oldsmobile got the assignment. They were GM's innovation division, the ones who'd pioneered the Rocket V8, the Toronado's front-wheel drive, the first turbocharged production car. If anyone could pull this off, it was Lansing. But think about what they were being asked to do. Design something your company has never built. Match competitors who have half a century of experience. Do it in 3 years. With a board that wants results, not excuses. With customers who are desperate for fuel economy right now. The pressure was enormous, the timeline was insane, and the temptation to cut corners was everywhere. So Oldsmobile's engineers got to work. And this is where the first critical mistake happened. So here's where GM made the decision that would haunt them for decades. They needed a diesel engine, they needed it fast, and they needed it cheap. What they did next was engineering malpractice. The Oldsmobile 350. If you were around in the 70s, you know this engine. Solid, reliable, nothing special. It powered everything from Cutlasses to Delta 88s. A perfectly adequate gasoline V8. GM looked at this engine and said, "We can make this a diesel. Same bore spacing, same external dimensions, same basic architecture. Just swap some parts, beef up a few things, and call it a day." The problem? Gasoline engines and diesel engines are fundamentally different machines. They look similar from the outside. They both have pistons and crankshafts and cylinder heads. But the forces involved aren't even in the same universe. Let me explain what happens inside a gasoline engine. You've got a spark plug that ignites a fuel-air mixture. The compression ratio is typically around 8-to-1, maybe 9-to-1. That means the piston squeezes the mixture to about 1/8 of its original volume before the spark fires. The resulting combustion creates cylinder pressures around 500 psi. That's what the Oldsmobile 350 was designed to handle. 500 psi, the block, the head bolts, the main bearing caps, the connecting rods. Everything was engineered for that number. Now here's what happens in a diesel. There's no spark plug. Diesel fuel ignites from compression alone. You squeeze the air so hard it gets hot enough to ignite fuel on contact. To make that happen, you need compression ratios of 22 to 1, sometimes higher. The Oldsmobile diesel ran at 22.5 to 1. Think about that for a second. You're compressing the air to 1/22nd of its original volume instead of 1/8. The pressures involved aren't just higher, they're in a completely different category. The Oldsmobile diesel saw cylinder pressures exceeding 1,500 psi. That's 3 times what the gasoline engine experienced. 3 times the force, 3 times the stress, hammering away at parts that were never designed for it. And here's the thing that still amazes me. They kept the same head bolts. The same head bolts. The gasoline 350 used 10 head bolts per cylinder head, torqued to specifications that worked fine for 500 psi. GM looked at those bolts and said, yeah, these will probably handle 1,500 psi. They didn't redesign them. They didn't add more bolts. They didn't fundamentally change the head bolt pattern. They just hoped for the best. The block casting was another disaster waiting to happen. Diesel engines need reinforced cylinder walls. They need beefier main bearing webs. They need thicker deck surfaces. The Oldsmobile diesel got none of that. They used essentially the same block casting as the gasoline engine with minor modifications. It was like taking a sedan and entering it in a demolition derby. Same body, completely wrong application. The main bearing caps tell the same story. Diesel engines produce torque differently than gasoline engines. The power pulses are sharper, more violent. Every combustion event is like a hammer blow to the crankshaft. The main bearing caps need to be massive, heavily reinforced, sometimes cross-bolted for extra strength. The Oldsmobile diesel used caps that were barely adequate for gasoline duty. They were undersized for the punishment a diesel delivers. Engineers working on the project knew this was a problem. They privately called it the time bomb. Not if it would fail. When? Why would GM do this? Simple math. A purpose-built diesel engine costs hundreds of millions of dollars to develop. It takes 5 years minimum. You need new tooling, new casting equipment, new assembly lines. You need thousands of hours of testing. You need to validate every component under diesel operating conditions. A conversion? That costs a fraction. You can do it in 2 years. You use existing tooling, you use existing assembly lines, you use existing suppliers. The accountants looked at the numbers and made their choice. The engineers raised concerns, the accountants won. This wasn't engineering, this was cost-cutting disguised as engineering. They took an engine designed for one job and forced it to do a completely different job. They knew the stresses were wrong. They knew the margins were thin. They did it anyway because the alternative was expensive and slow. But the conversion problems were just the beginning. The real disaster came from what they didn't change. Let's talk about what actually killed these engines, because it wasn't one thing. It was 2 things working together in a kind of mechanical conspiracy that guaranteed failure. The first killer was the head gaskets. Now, in a gasoline engine, the head gasket seals the combustion chamber, keeps coolant and oil where they belong, and generally just does its job without drama. The compression ratio in a typical gas engine of that era was maybe 8 to 1. The Oldsmobile diesel ran at 22.5 to 1. That's nearly 3 times the pressure trying to push the head away from the block on every single combustion stroke. To handle that kind of force, you need serious clamping pressure from the head bolts. The bolts have to be strong enough and numerous enough to keep that head absolutely planted against the block. My GM's solution was to use the same basic head bolt pattern they used on the gasoline version. 10 bolts per head. Same diameter. Same thread pitch. Problem was, those bolts weren't designed for diesel compression loads. Under the repeated thermal cycling of normal operation, the bolts would stretch. Not a lot. We're talking thousandths of an inch. But thousandths of an inch is everything when you're trying to seal against 2,000 psi of combustion pressure. Once the bolt stretched, the clamping force dropped. Once the clamping force dropped, the head gasket started to leak. And here's where it gets ugly. A diesel engine cannot compress liquid. This is basic physics. Liquids don't compress. When coolant leaked past a failed head gasket into the cylinder, the piston would attempt to compress that liquid on the next stroke. Something had to give. The piston couldn't stop. The crankshaft was still spinning. All that energy had to go somewhere. Usually it went into the connecting rod. The rod would bend. Sometimes it would snap clean in half. And when a connecting rod fails at speed, it doesn't just stop. It punches through whatever's in its way. Usually that meant the side of the block. Dealers called it throwing a rod. Owners called it much worse. The repair for a thrown rod wasn't a repair. It was a new engine, and the new engine had the same head bolt problem the old one did. But here's the cruel irony. Even if your head gaskets held, the fuel system would kill you. And if you fixed the fuel system, the head gaskets would go. Owners were trapped in a cycle of $1,000 repairs that never actually solved anything. On the fuel injection system was a Rusamaster rotary pump. Stanodyne made it. It was a proven design that worked beautifully in agricultural and industrial applications. Tractors ran these pumps for tens of thousands of hours without issues. The pump itself wasn't the problem. The problem was what Americans put in their fuel tanks. European diesel fuel in the late 1970s was relatively clean, low sulfur content, minimal water contamination, tight quality controls. American diesel fuel was basically whatever the refineries felt like producing that week. Higher sulfur content, more particulates, and water, lots of water. See, diesel fuel is hygroscopic. It absorbs moisture from the air. American fuel distribution systems weren't designed with the same care as European ones. Fuel sat in tanks. Condensation formed. Our water accumulated at the bottom of storage tanks and got pumped right into customer vehicles. The Rusamaster pump had extremely tight tolerances. We're talking clearances measured in 10,000ths of an inch. Water in the fuel would cause microscopic corrosion on the pump's internal surfaces. Sulfur compounds would accelerate that corrosion. Particulates would score the precision machined surfaces. The result was injection pump failures averaging under 20,000 miles. Some pumps didn't make it to 10,000. The symptoms started subtle: hard starting, rough idle, loss of power. Then the pump would fail completely and the engine wouldn't run at all. Replacing the pump cost several $100s in parts alone, plus labor. And here's the kicker. Now the replacement pump would fail just as quickly because the fuel quality hadn't changed. Owners would pay for a new pump, drive another 15,000 miles, and be right back at the dealer with the same symptoms. Some owners tried fuel additives. Some tried water separators. Some tried buying fuel only from specific stations they trusted. None of it really worked. The fundamental problem was that the fuel system was designed for fuel that didn't exist in America. So you had two failure modes feeding each other. The head gasket failures would contaminate the oil with coolant. Contaminated oil would accelerate wear throughout the engine, including the injection pump. Injection pump problems would cause rough running, which increased thermal stress on the head gaskets. Each problem made the other worse. Dealers saw the same customers over and over, same complaints, same repairs, same failures a few months later. The service departments were drowning in warranty claims they couldn't actually fix. GM knew about these problems. What they did next made everything worse. So the engines were failing. Dealers were overwhelmed. Customers were furious. And GM's response was to blame the customers. That's not an exaggeration. When owners started flooding dealerships with complaints about their diesels dying, GM's official position was that these people were doing something wrong. Specifically, they were buying the wrong fuel. The company issued service bulletins suggesting that customers were filling up at gas stations that sold contaminated diesel. The solution? Find a different gas station. Maybe try adding fuel additives. That should fix it. It didn't fix it. One owner in Minnesota documented 17 trips to the dealer in 18 months. 17. His head gaskets were replaced twice. His injection pump was replaced 3 times. His total repair bills exceeded the original purchase price of the car. And GM's response to this man was to suggest he was buying fuel from the wrong station. The same station, apparently, that every other diesel owner in Minnesota was also using. Because they were all having the same problems, the fuel additive recommendation was particularly insulting. GM suggested owners pour various additives into their tanks to help the injection system cope with American diesel fuel. These additives cost money, they required effort, and they addressed exactly 0 of the actual engineering problems with the engine. The head bolts were still too weak. The block was still cast iron, mated to aluminum heads with inadequate clamping force. The injection pump was still destroying itself because it was designed for a different fuel specification entirely. But here's where it gets worse. When engines failed catastrophically and needed replacement, GM sent dealers new engines. Same design, same flawed head bolts, same inadequate gaskets, same injection pumps that couldn't handle American diesel. Owners would wait weeks for a replacement engine, pay for the labor, even if the parts were covered, and then watch the same failures happen all over again. Some owners went through 3 engines, 4 engines. The warranty would run out, and they'd be stuck with a vehicle that was essentially worthless. Imagine paying $12,000 for a new car in 1978. That's over $50,000 in today's money. Now imagine that car dying in the dealer's lot 3 times before the first oil change was even due. That was reality for thousands of Americans who trusted the General Motors name. By 1980, the lawsuits started. A class action was filed representing owners across the country who had purchased these diesel vehicles expecting the reliability that GM had promised. The complaints were remarkably consistent: engines that wouldn't start, engines that overheated, engines that consumed coolant at alarming rates, engines that simply stopped working with no warning. And in every case, owners who had been told by GM that they were somehow at fault. The settlement, when it finally came, was almost as insulting as the original response. GM offered extended warranties. Not refunds, not buybacks, not compensation for the thousands of dollars owners had already spent on repairs. Just a promise to keep fixing the same broken design for a little while longer. Many owners rejected the settlement. They wanted their money back. They wanted GM to admit that the engine was defective from the factory. They didn't get either. The financial devastation was real. These weren't wealthy collectors buying toys. These were families who had stretched their budgets to afford a new car because the fuel savings would pay for the higher purchase price over time. Instead, they got vehicles that spent more time in the shop than on the road. They got repair bills that exceeded their monthly car payments. They got trade-in values that collapsed because nobody wanted a used diesel Oldsmobile, and many of them got stuck making payments on cars that didn't run, couldn't be sold, and couldn't be fixed. Dealers suffered too. Service departments were overwhelmed with warranty work that didn't pay well and didn't actually solve the problems. Salespeople watched their reputations collapse as customers they'd sold diesel vehicles to came back angry, betrayed, and very vocal about their experiences. Some dealers quietly started steering customers away from the diesel option entirely, even though GM was still pushing them to sell it. The company had a choice: admit the fundamental design flaws and recall the engines for a proper fix, or deny, deflect, and hope the problem went away. They chose denial. If you're finding this story as frustrating as those owners did, hit subscribe. We cover engineering disasters like this regularly. Now, let's look at what GM actually tried to do to save this engine. If you're still here, you're my kind of viewer. Subscribe if you want more of these deep dives. We do this every week. All right, back to it. So by 1979, GM knew they had a disaster on their hands. Engines were failing by the thousands. Lawsuits were piling up. Dealers were screaming. And the warranty claims were bleeding money at a rate that made accountants physically ill. The question was simple. Could they fix it? The answer was complicated. In 1980, GM rolled out what they called the revised diesel program. Engineers went back to the drawing board and addressed the most obvious failure points. First up, on the block itself, they added reinforced main bearing caps, beefier, stronger, designed to handle the additional stress that diesel combustion created. On paper, it looked good. They also upgraded the head bolts. Remember those 10 head bolts per cylinder that were never designed for diesel loads? GM switched to higher-grade fasteners with better clamping force. The theory was sound. More clamping pressure means better head gasket sealing. Better sealing means no coolant contamination. No coolant contamination means no catastrophic failures. Then came the fuel system modifications. Engineers added improved filtration systems to catch contaminants before they reached the injection pump. They redesigned some of the fuel delivery components. They issued new service bulletins to dealers explaining proper fuel system maintenance. Hey, here's the thing. All of these fixes helped, marginally. The failure rates dropped from catastrophic to merely terrible, but the fundamental problem remained untouched. You cannot engineer your way out of a flawed foundation. The block was still based on the Oldsmobile 350 gasoline architecture. The cylinder walls were still too thin for sustained diesel pressures. The cooling passages were still inadequate for the heat loads. The entire engine was still trying to be something it was never designed to be. It's like reinforcing the walls of a house built on sand. You can add all the steel beams you want. The foundation is still sand. By 1982, GM decided they needed a completely new approach. Sort of. They introduced the 5.7-liter diesel. This was supposed to be the real fix. The engine that would restore faith in GM diesel technology. Engineers made significant changes, stronger head bolts, improved cooling passages throughout the block, better fuel filtration as standard equipment, revised injection timing, updated gasket materials. On the specification sheet, it looked like a different engine. It wasn't. The 5.7 still used the same basic architecture, the same fundamental design philosophy, the same compromises that had doomed the 5.7-liter from the beginning. Yes, it was more robust. Yes, it failed less frequently. But it still failed at rates that would have been unacceptable for any other manufacturer. Owners of the new 5.7-liter diesels started reporting the same symptoms: head gasket failures, coolant contamination, injection pump problems. The timeline was longer. Maybe you got 60,000 miles instead of 30,000. But the destination was the same, and by this point, the damage was done. See, reputation doesn't care about engineering revisions. Reputation doesn't read service bulletins. Reputation is built on stories. And the stories people were telling about GM diesels were devastating. By 1983, diesel resale values had collapsed completely. Owners were trading in 3-year-old Oldsmobile diesels for less than half what they'd paid. Some dealers refused to take them at all. They'd rather lose the sale than have another diesel sitting on their lot, waiting to become someone else's problem. The warranty costs were staggering. GM eventually spent more than $500 million on diesel-related warranty claims. $500 million. In 1980s dollars, adjusted for inflation, that's well over $1 billion today for an engine program that was supposed to save money on fuel. The irony is almost poetic. GM built the diesel to capitalize on fuel economy concerns. They ended up spending more on warranty repairs than they ever could have saved on gasoline. Production limped along through 1983, then 1984. By 1985, GM pulled the plug entirely. The Oldsmobile diesel was dead. No more passenger car diesels from General Motors. The experiment was over. But the consequences were just beginning. Here's what GM didn't understand at the time. They hadn't just killed a product line. They hadn't just lost money on warranty claims. They had fundamentally altered how American consumers viewed diesel engines. An entire generation of car buyers now associated diesel with unreliability, with expensive repairs, with engines that self-destructed without warning. This wasn't a GM problem anymore. This was an industry problem. Every manufacturer who wanted to sell diesel cars in America now had to overcome the Oldsmobile stigma, and most of them decided it wasn't worth the effort. The European manufacturers, who had been building reliable diesels for decades, they looked at the American market and saw a wasteland. Why fight that battle? Why try to convince buyers that your diesel was different when they'd already been burned? The Oldsmobile diesel didn't just fail as a product, it changed the entire American auto industry. The lawsuits settled, the warranties expired, the last Oldsmobile diesel rolled off the line in 1985. But the damage was just getting started. See, engines fail all the time. Companies recall products, fix the problems, move on. Consumers forget. That's how it usually works. But the Oldsmobile diesel was different. It didn't just fail. It failed spectacularly, publicly and expensively for hundreds of thousands of American families. And those families talked. They talked to their neighbors, their co-workers, their kids. They told stories about the Oldsmobile that stranded them on the highway, the Cadillac that needed a new engine at 30,000 miles, the Delta 88 that spent more time at the dealer than in their driveway. And here's what happened next. In 1981, diesel passenger cars represented about 6% of the American market. Not huge, but significant. Growing. By 1985, that number had collapsed to under 1%. And it stayed there. For decades, one engine, one company, one catastrophically bad decision, and diesel cars in America were essentially dead. Now, compare that to what was happening across the Atlantic. In Europe, diesel technology kept advancing. Mercedes, BMW, Volkswagen, Peugeot, they all invested heavily in diesel passenger cars throughout the 80s and 90s. They solved the problems that Oldsmobile never bothered to address. Better fuel systems, proper head bolt engineering, turbocharging that made diesel cars actually enjoyable to drive. By 2000, diesel passenger cars represented over 30% of new car sales in Europe. By 2010, that number exceeded 50% in many countries. 50%. Half of all new cars sold in Germany, France, Italy running on diesel, getting 40, 50, sometimes 60 miles per gallon. Clean, quiet, refined diesel engines that had nothing in common with what Oldsmobile built except the fuel they burned. And in America, still under 3%, still stuck with the memory of engines that destroyed themselves before the first oil change. The gap is staggering when you actually look at it. In Germany today, over 40% of new cars are diesel. In America, it's barely 3%. That's not a small difference. That's a completely different automotive culture, and a huge part of that gap traces directly back to Lansing, Michigan, 1978. GM's response to the disaster was predictable. They abandoned diesel passenger car development entirely. For 25 years, General Motors didn't offer a single diesel engine in a passenger car sold in America. 25 years. An entire generation of engineers never worked on diesel passenger car technology at GM. The institutional knowledge, the research, the development infrastructure, all of it evaporated. Ford saw what happened to GM and drew the obvious conclusion. They'd been developing their own diesel passenger car program. They killed it. Chrysler did the same thing. The entire American auto industry looked at the Oldsmobile disaster and collectively decided that diesel passenger cars weren't worth the risk. The Japanese manufacturers were even more cautious. Toyota, Honda, Nissan, they all had diesel technology. They sold diesel cars in Europe, in Asia, everywhere except America. They looked at the American market. I saw the wreckage GM had created and decided to stay away entirely. Why risk their reputation on a technology that American consumers had learned to hate? That left exactly one option for Americans who wanted a diesel car: Volkswagen. For nearly 3 decades, if you wanted a diesel passenger vehicle in America, you bought a Volkswagen or you bought nothing. One company, one choice, in a market of 300 million people. Think about what that means. Every time you see a European diesel car that gets 50 miles per gallon and wonder why we can't buy it here, part of the answer is an engine that stopped production 40 years ago. Every time an automaker decides not to bring their efficient diesel model to America, they're making a calculation that includes the Oldsmobile disaster. The market research still shows it. American consumers, especially older ones, still associate diesel with unreliability, with smoke, with engines that self-destruct. The irony is brutal. Modern diesel technology is genuinely impressive. Common rail injection, turbocharging, particulate filters, these engines are clean, efficient, and reliable. European consumers figured that out decades ago. American consumers never got the chance because one company poisoned the well so thoroughly that nobody wanted to drink from it again. GM eventually came back to diesel, sort of. They started offering diesel options in trucks and SUVs in the 2000s. But passenger cars, it took until 2014 for GM to offer another diesel passenger car in America, 36 years after the original disaster. And even then, it was a Chevrolet Cruze with a European-designed engine, not something developed in Detroit. 36 years. That's how long the shadow of the Oldsmobile diesel stretched. That's how much damage one bad engine can do when a company prioritizes cost savings over engineering integrity. So what's the final lesson from the Oldsmobile diesel disaster? So here's the thing. The Oldsmobile diesel disaster happened almost 50 years ago. Different era, different technology, different cars. But the pattern? The pattern keeps repeating. Look at Tesla in the early 2010s. Revolutionary technology, massive demand, production pressure that bordered on insane. And what happened? Panel gaps you could fit your finger through, paint that looked like it was applied by a toddler, doors that didn't align. Elon Musk was sleeping on the factory floor trying to hit production numbers. Sound familiar? Hey, rush to market. Cut corners where you think nobody will notice. Deal with the consequences later. The difference is Tesla survived it. Barely. They had something GM's diesel never had. The underlying technology actually worked. The cars drove well. The batteries held up. So customers forgave the build quality issues because the core product delivered on its promise. The Oldsmobile diesel couldn't make that claim. But here's a darker parallel. Boeing, the 737 MAX. When Boeing decided to update the 737 rather than design a new aircraft from scratch, they made the exact same calculation GM made in 1975. Cheaper, faster. The accountants loved it. The engineers had concerns. Management overruled them. We know how that ended, too. 346 people dead, billions in losses. A reputation that may never fully recover. The 737 MAX wasn't a bad aircraft because Boeing engineers couldn't design good planes. It was a bad aircraft because the business side of the company made engineering decisions, cost-cutting on safety-critical systems, rushing certification, hiding problems from regulators, the Oldsmobile diesel playbook written 40 years earlier. And GM themselves? Did they learn from the diesel disaster? The ignition switch scandal suggests they didn't. For over a decade, GM knew their ignition switches could fail and cut power to vehicles while driving. Airbags wouldn't deploy. Power steering would fail. At least 124 people died. GM knew. They calculated the cost of a recall versus the cost of lawsuits. The lawsuits won. Same company, same culture, different decade. There's another legacy of the diesel disaster that's harder to measure, but just as real. Electric vehicle range anxiety. That fear that your car won't go as far as promised. That the technology will fail you. That the manufacturer is lying about capabilities. Where do you think that distrust came from? GM spent the 1980s and 90s trying to convince Americans that new technology was safe and reliable, and Americans remembered the diesel. They remembered being stranded. They remembered the lies. They remembered the dealers who blamed them for engine failures. That institutional memory doesn't disappear. It gets passed down. Your father tells you never to buy a GM diesel. You tell your kids to be skeptical of any new automotive technology that sounds too good to be true. The next time you hear about a company rushing a product to market to beat competition, remember the Oldsmobile diesel. Some lessons cost billions to learn, and apparently some companies have to learn them more than once. Engineering shortcuts always cost more in the long run. Always. The only question is who pays. Sometimes it's the company, sometimes it's the customers, sometimes it's both. And that brings us to the final verdict on GM's diesel disaster. $500 million. That's what the warranty claims and lawsuits cost GM directly, and that number sounds enormous until you realize it's basically a rounding error compared to the real damage. Think about it. For 40 years after this disaster, American consumers refused to buy diesel cars, not just GM diesels, any diesel. European manufacturers who had perfectly reliable diesel technology couldn't give them away in the United States. The entire market segment was poisoned by one engine from one company that couldn't be bothered to do the job right. Some analysts have tried to calculate what GM lost in diesel sales over those 4 decades. The estimates run north of $50 billion. That's not a typo. $50 billion. And that's just GM. The ripple effects across the entire American auto industry are genuinely incalculable. But here's what really sticks with me. GM's reputation for quality never fully recovered. Not really. The jokes about government motors, about cars falling apart, about American manufacturers cutting corners, a lot of that traces back to decisions made in Lansing in 1977. One engine, one shortcut. Decades of consequences. The Oldsmobile diesel proved something that every engineer should have tattooed on their forearm. Cutting corners cost more than doing it right. Always. Every single time. If you owned one of these engines, or your family did, I want to hear about it in the comments. Those stories deserve to be told. And if you made it this far, subscribe. We do deep dives like this every week. See you in the next one.